Okay, so we're going to do a little review, Q-2-4 action. Start with the waves problem, and then we'll go from there. I'll try to break it down in each section. Yes, we are in negative, and it does look a little weird, but, you know, whatever. So, here we go. Alright, so we got a small fishing boat. It starts at the bottom of the wave and moves up 1.3 meters in 4 seconds and down 1.3 meters in 4 seconds. When the boat is at its highest point, the nearest boat is 4 meters away. We'll get the wavelength out of the way. So crest to crest, trough to trough, node skip a node, that's 4. So, you know, when this, we got our wave up here and the next wave, and the distance is lambda, or the wavelength. Amplitude, maybe not as easy as you might think. 1.3 meters, that's the distance that the boat goes up and down. So it starts at the bottom, goes to the top, 1.3 meters. So we want to take 1.3 divided by 2. That'll be our amplitude. So 0.65. Frequency, it's just 1 over the period. Takes 4 seconds on the way up and then 4 seconds on the way down. So to go from trough to trough is 8 seconds. So we're going to say 1/8. I don't know what that is. I'll have to punch in my calculator here in a minute. And then the period, 4 and 4 is 8 seconds. So that's the first thing, is just interpreting the information above. And remember, we have 100 kilograms for the mass. So we're ready to do each of the individual parts here. We can do our wave real quick, get that out of the way too. So remember, we're starting at the trough. The trough is negative 0.65. We're going to go up to the crest. It's going to be located at positive 0.65. And we do something like this. Go up and down and up and down. It said for at least 2 periods, and that's what we did. And we can label our properties. Crest can also be called the antinode. Nodes are where it crosses the x-axis. This is called the trough, and this is also called the antinode. The distance from crest to crest or trough to trough is the wavelength. You just have to label it once. There was 3 places I could have labeled it. X to the crest, X to the trough. That is the amplitude. So I think I got everything there. I got wavelength, node, antinode, and amplitude. I think I probably did more than I needed. Oh, crest and trough. So then what I want to do is I want to do some of the harder math. We'll start by calculating wave velocity. It says it right here. It's kind of hidden. Pretty simple. It's just frequency times wavelength. So we go up above the frequency, 1/8, wavelength, 4. So we get a half. That's how fast the energy is moving, or the wave. That's the first thing. It says spring constant, K. Even though there's not a spring, we can still have a spring constant. It's just how stretchy the media is. So 2 pi quantity squared. And we're going to multiply that times the mass, and we're going to divide by the period squared. I think 2 pi quantity squared is 49.5, and then the mass is 100. I'm going to put in the period, which is 8 squared, 64. Looks like I'm going to have to grab my calculator here. Hold on one second. Sorry, I was kind of avoiding that, but now that we're here, ooh, look at that, fancy. So we got 2 pi quantity squared times the mass, 100, divided by 8 squared. So that's 61.68 will be our spring constant. Don't forget the units. I don't remember if I put the units on the quiz tomorrow. You know, probably not. So we want to get into that habit. 61.68, there's a dot there. And then we're ready to calculate the last thing, which is the object's velocity. In this case, the boat. What I want you to keep in mind is that this fluctuates, right? Like, depending on where it's at. It's sometimes 0 and sometimes it's this max velocity. And that's what we're going to find is when it crosses the x-axis or the max velocity. So we have a relationship 1/2 Ka squared, which is the potential energy, and then we could set that equal to kinetic energy, which is 1/2 mv squared. And we derive this whole thing, and we get v by itself, so we get square root of Ka squared divided by m. We'll just plug that in. 61.68 times the amplitude from our things that we figured out at the beginning is 0.65, and we square that, and we divide it by the mass, as the boat is 100 kilograms. And we can find out how fast it's going. So we plug it into our old calculator again. So we're going to take our answer, we're going to multiply that by 0.65 squared, and we're going to divide by 100, and we got to square root everything. And you get 0.51. So it's pretty close, but not exactly the same. So the max object velocity is 0.51 meters per second. Of course, that's always changing. Sometimes positive, sometimes it's negative. Depends on if you want to include your swirl concept or not. But anyway, that's it for the first one. We'll have another video up here with the next one in just a second. That was 6